Chapter 4, Section 17, Advanced Method for Univariate Outlier Detection, Part 2. As advanced methods for univariate outlier detection, the previous section focused on trimmed mean and median and MAD. This section covers robust Z-Score and Winsorization. To detect outliers based on standard deviation, we can use a robust Z-score instead of the usual Z-score. A robust Z-score is calculated by subtracting the median from the data value and dividing the result by multiplying 1.4826 with MAD. Using this robust Z-score makes our detection less susceptible to outliers. MAD is a robust measure of spread, not affected much by outliers. However, MAD tends to underestimate the standard deviation when the data is from a normal distribution. So, to make MAD work like the standard deviation, we scale it with a constant. Let's implement the outlier detection using robust Z-scores in Python. First, calculate the median and MAD as before. Next, calculate the robust Z-score. This is done according to the formula. Then, we set the threshold value. Here, we set it to 3, meaning that we consider any absolute value of the robust Z-score greater than 3 to be an outlier. Using this threshold, detect outliers. Let's look at the results. Only data points with large values are detected as outliers. Since robust Z-score is also based on median and absolute values, it seems that in this data points with large values and a large deviance from the median were more likely to be considered outliers. The Winsorization replaces a certain percentage of upper and lower values of the data with the largest or smallest value in the range. This allows for calculations that take into account the entire dataset while minimizing the effects of extreme outliers. For example, replacing the top 1% of data with the second highest value and the bottom 1% of data with the second lowest value reduces the distortion of IQR and the standard deviation due to outliers. Let us replace the largest value with the second largest value and the smallest value with the second smallest value. We can implement Winsorization by this code. Let's start with the first part. First, import Winsorize from scipy.stats.mstats. Next, Winsorize the value column of data frame df. The argument limits is set so that the lower 10% of the values are replaced with the 10th percentile of the data and upper 10% with the 19th percentile. The Winsorized value is inserted to the original data frame as a new column, Winsorized value. The mean and the standard deviation of the Winsorized data are then calculated. Let's go on to the second half. Set the threshold for outliers based on the mean and the standard deviation of the Winsorized data. Next, create a new column that records whether or not the calculated threshold is exceeded by the Winsorized data. This column will record true if the column value exceeds the threshold and false otherwise. Let's look at the result. Only the data points with the largest values were detected as outliers. The two data points with the smallest values did not differ much from each other, so replacing the smallest value with the second value from the bottom may have a little impact on the result. We have introduced 5 methods, including the IQR-based iterative method, explained in the previous section. Let me summarize the pros and cons of each method. The IQR-based iterative method can be applied to non-normally distributed data by relying on the IQR. However, it should be noted that the setting of the threshold value, that is, the IQR multiplier, can easily become arbitrary. The method using the trimmed mean plus minus 3 standard deviation is based on the mean and the standard deviation and easy to calculate and interpret. However, the mean and standard deviation are susceptible to outliers, which may lead to inappropriate results unless the data is close to a normal distribution. The method using the median plus minus k times MAD has the advantage of being less susceptible to outliers by relying on the median and MAD. However, it should be noted that the results of outlier detection can vary greatly depending on the setting of the value of k. The method using a robust Z-score can minimize the influence of outliers without eliminating them. However, when the data size is small, the median and MAD are less representative, making them unsuitable for datasets with small sample sizes. The advantage of the combined winsorization and IQR method is that it preserves the data structure by replacing outliers with specific values rather than eliminating them. However, it should be noted that the adjustment criteria for winsorization can be arbitrary. As we have seen, there are various methods for outlier detection, each with its advantages and disadvantages. In order to select the best method, we can take the following steps. First, check the shape of the data distribution using histograms or QQ plots. Second, determine whether we should remove the outliers or suppress the impact of outliers. Then, try multiple methods according to the objectives determined in the previous step and compare the results. Based on the results, we can determine the best method. Thank you for watching. If you have any questions, feel free to ask in the comments. Your feedback is always appreciated.